All right, hello and welcome. Today we're going to pull back the curtain on the virtual robot race beta. We're not just going to look at what it is, but really get into the nitty-gritty of why it was designed this way. So let's jump right in.
So right away, I need to get something straight. When you hear robot race, I bet your mind immediately goes to, a simple video game. And I get that. But I want you to push that thought aside because what we're talking about today is so much more than that. This thing was built with a really serious goal.
Okay, so what is the virtual robot race, or VRR? Well, at its core, it's an educational platform. Think of it as a sandbox, a playground specifically designed to let you get your hands dirty with the big three of modern robotics: control engineering, computer vision, and machine learning. And the best part? It wraps all of that up into one single cohesive project. So, a learning platform that's not just about racing. But that begs the question, right? If it's a serious educational tool, why make it a race at all? Well, let's unpack the design choice there. Framing it as a race actually gives us three huge advantages for learning. First off, you get super clear success metrics. Your lap time doesn't lie, right? It's a hard number that tells you exactly how well your code is doing. Second, it naturally builds in a difficulty curve. Your first goal, just get the car moving. Then finish a lap. Then you can start worrying about shaving off seconds. It's this perfect step-by-step progression. And third, well, let's be real. A little competition is fun. Having a leaderboard is a fantastic motivator to keep you coming back and making your creation just a little bit better each time.
All right, let's get into the architecture. This is where, for me, the design philosophy really starts to shine. The whole setup is intentionally built to mirror how robotics development happens out there in the real world. So VRR is basically split into two halves, Unity and Python. And this separation is absolutely key. Think of it like this. Unity is the body and the world. It handles all the physics, the 3D graphics, and it generates the images from the car's camera. Python is the brain. That's where you do all the thinking, writing your control logic, processing those images from the camera, and training your AI models. Each part is doing exactly what it's best. And this setup isn't just for convenience. It's a direct copy of how real robotics works. A physical robot has its hardware, the motors, the sensors, the chassis, and then it has the software that controls it. In our case, Unity is acting as the hardware. It is the robot. This is huge because it means the Python code you're writing, the brain you're building, could theoretically be lifted and, with some tweaks, dropped into a real physical robot. That's the whole idea behind sim-to-real development, and it's a core part of the philosophy here.
So what does this actually mean for you, the person learning? Well, it means you can focus. Since Unity is treated like a black box, the hardware, you don't have to learn C#. You don't have to mess around in the Unity editor. You can pour 100% of your energy into the Python side of things. And that's where the real magic happens. The algorithms, the logic, the AI, that's the heart of the whole experience. Okay, so now that we have the architecture, let's see how it guides you through the learning process. VRR gives you 4 different control modes, but these aren't just options to pick from. Think of them as a deliberate 4-step journey designed to take you from Hello World all the way to a fully autonomous AI.
So, you might be wondering, why not just jump straight to the cool part? Let's build the AI. And believe me, that's a super common urge. The problem is, if you try to automate something you don't deeply understand yourself, you're just going to get frustrated. VR intentionally makes you slow down and build up a solid foundation first. And here's that 4-step journey. There's a real reason for this specific order. Step 1, keyboard mode. You just drive the car yourself. This gives you a feel for the physics and, importantly, lets you collect your first batch of data. Step 2, table mode. This is where you start to see control as just a sequence of data in a file. It shifts your perspective. Then step 3, the rule-based mode. This is critical. You have to explicitly write the code for that sense, think, act loop. And only after you've done all that do you move on to the final step, AI mode, where you teach the machine to learn that same logic, but directly from the data you've gathered. So let's really compare those last 2 steps, because this is important. A rule-based system is what we call a white box. You can look inside and see everything. The logic is clear. If you see the white line here, then calculate the steering angle like this. It's easy to debug, but it's brittle. Change the track, and you might have to rewrite the whole thing. Now, an end-to-end AI, that's a black box. You feed it an image, and it spits out a steering command. It's powerful, it can adapt to new tracks, but good luck figuring out exactly why it made that one weird turn. And here's the key takeaway. By making you build that white box first, VRR ensures you truly understand the problem that you're later asking the AI to solve. You're not just feeding data into a mysterious black box and hoping for the best. No, you're automating a logical process that you've already struggled with and built by hand. And that, right there, completely demystifies what the AI is actually doing. This leads us perfectly into what is maybe the single most important part of the VRR design philosophy. And it's this: data isn't a side effect. It's not just something that gets generated while you run the simulation. In this system, data is the absolute center of the universe. Okay, so you've just done a run. The system saves a whole bunch of image files, and you see a name like this: frame_001234 JPEG. On its own, it's just a picture, right? A single snapshot from the robot's point of view. But what does it actually tell us? And this is where it all clicks. Every single one of those image files has a matching row in a metadata file. This file is the ground truth. It tells you that at the exact millisecond that picture was taken, the torque was 0.5, the steering angle was 0.08, and the battery was at 99.5%. The image, what the robot saw, is perfectly synchronized with what the robot was doing and its internal state. This is such a powerful idea. In VR, every single run, whether it's you driving or your AI driving, creates a brand new lesson. That driving log, that collection of images and data, isn't just a byproduct. It literally is the curriculum. Your successes, your mistakes, every corner you take, that becomes the textbook that you use to teach your AI. Now, you might have spotted that SOC, or state of charge column, in the data and wondered about it. That was put there for a very specific reason. This whole project isn't just about going as fast as you can. It's about teaching energy management. It adds a real-world constraint. The AI has to learn that flooring it all the time might win you a few seconds now, but it'll drain the battery and you won't even finish the race. It's a trade-off. And as a bonus, it's a great, simple introduction to what's called multimodal learning, making the AI reason using both an image and a simple number at the same time. Okay, so as you start to dig into VRR, you're going to notice some things. You'll see parts that aren't perfectly polished or optimized. And I want to tell you right now, that's not a bug. It's a feature. The platform has these intentionally left blank spaces that are, in a weird way, the most important part of the design. Look, VRR isn't supposed to be a polished, finished game. It's a framework. It gives you the car, the track, and the tools, but it intentionally leaves a ton of room for you to experiment. Do you think a different model architecture would work better? Awesome. Go build it. Is the steering a little wobbly? Great. That's your job to design a filter to fix it. Think you can blend the rule-based and AI modes in a clever way? That's the challenge. These aren't problems with the beta. These are the assignments. So let's wrap all this up. What is this thing really offering? And more importantly, who is this for? Really, this platform was built with a few groups of people in mind. It's for university students in engineering or CS who are tired of just theory and want to build something real. It's for early career engineers who need a solid, practical project for their portfolio. It's definitely for educators who are looking for engaging, hands-on materials for their STEM classes. And of course, it's for all the hobbyists out there who are just fascinated by autonomous driving and want to dive in. So, in the end, that's what VRR gives you. It gives you a car, a track, and a whole toolbox. It provides a roadmap to get started, but all the most important decisions, those are left to you. The platform isn't just asking you to train some model. It's asking a much bigger, more personal question. With this car, this data, and these challenges, what kind of AI would you raise?